Welcome back to our YouTube channel Gurmantra Shiksha Ka Granth. I am your educator Nidhi Dua and I warmly welcomes you at this platform. So guys, in today's lecture we are going to discuss a very important topic that will be based on distinguished test for different functional groups. Okay, so as you know, in our organic chemistry we have different functional groups like alcoholic group, phenolic group, carboxylic group, aldehyde, ketones and amino acids. So in today's lecture our main objective will be to identify the functional groups present in an organic compound, and in today's lecture we are going to discuss the 6 major points that you can see on your screens. Okay, so number 1 test is for test of unsaturation. Okay, so you know it very well. We use the term unsaturation and saturation in organic chemistry, basically in hydrocarbons. So hydrocarbons are the organic compounds that contains only carbon and hydrogen. The compounds which has only carbon and hydrogen in their molecular or empirical formula, they are known as hydrocarbons. Hydrocarbons are distinguished between two, that are saturated hydrocarbons and unsaturated hydrocarbons. In simple language, you can say alkanes are the saturated carbons, or the hydrocarbon that contains carbon-carbon single bond are known as saturated hydrocarbons, while unsaturated hydrocarbons are your alkene and alkyne. Hydrocarbons that contains carbon-carbon double bond or triple bond are known as unsaturated hydrocarbons. As you know it very well, in alkenes double bond are present, while in alkynes triple bonds are present. Now, there are 2 tests for determining the unsaturation in an organic compound. Number 1 test is bromine test. When you react bromine with alkene or alkyne, you will get a colorless solution, or you can say you will get a colorless product. In this test, the orange-red color of bromine solution disappears when it is added to an unsaturated organic compound. First of all, you have to remember this point. The color of bromine solution is orange-red color. And second point is, when you mixes Br2 with any unsaturated compound like alkene or alkyne, then the product obtained will be a colorless compound. Okay. Next is Bayer's test. First of all, you have to remember this point. In Bayer's test, you will use alkaline KMnO4. That's why this Bayer's test is also known as alkaline KMnO4 test. In this test, pink color of KMnO4 disappears when alkaline KMnO4 is added to the unsaturated hydrocarbon. Okay, as you can see here, when alkyl KMnO4 is reacting with the double bond, then the colorless product is obtained. The disappearance of pink color may take place with or without the formation of brown precipitate of MnO2. This is also very important point. Next is test for alcoholic groups. First of all, you need to understand that what are alcohols. Alcohols are the compounds in which hydroxyl group is the OH group that is linked to aliphatic carbon chain, a simple carbon chain, or in the side chain of the organic compounds. We have different methods to detect the alcoholic group present in a compound or not. Number 1 method is sodium metal test. When a simple metal like active metal like sodium is reacting with alcohol, then it liberates a gas, and that gas is hydrogen gas. Okay, as you can see here, a alcoholic group 2ROH plus reacting with 2 sodium, then this will form a sodium alkoxide, that is 2RONA plus H2 gas. Second method is Ester test. When alcohol reacts with carboxylic acid, they will form a compound known as esters, and these esters have a smell like fruits. Okay, so alcohol reacts with carboxylic acid to form fruity smelling compound that is known as esters. Okay, the reaction between alcohol and carboxylic acid is called as esterification, and this is catalyzed by an acid such as concentrated sulfuric acid. For example, you can see here we have methyl alcohol. Methyl alcohol, when reacting with acetic acid, then this will lead to the formation of methyl acetate, that is your ester group. Next, third test is acetyl chloride test. In this test, acetyl chloride is reacting with alcohol to form esters, and particularly in this test, hydrogen chloride gas will be liberated. Okay, so the hydrogen chloride formed gives the white fumes of ammonium chloride with ammonium hydroxide. As you can see here, we have alcoholic group ROH reacting with acetyl chloride, that is CH3C double bond OCl. Then this will lead to the formation of an ester compound and the liberation of hydrogen gas. Fourth is the Isoform test. This test is very important. From this test, question could be asked directly. This test is given by acid aldehyde. If you talk about in the aldehydic group, only acid aldehyde will give the Isoform test, while all the methyl ketones and all the alcohols that contains CH3CHOH group will give this Isoform test. When alcohol is warmed with sodium hydroxide solution, sodium hydroxide solution is NaOH, a yellow precipitate of Isoform is formed. Means if you have a alcoholic compound, for example 2-propanol, when reacting with iodine I2 in presence of sodium hydroxide, then this will lead to the formation of acetone, a ketonic group, plus 2NaI plus 2H2O, and this will be your yellow colored precipitate. Next is test for phenolic groups. First of all, phenols are the compounds that contains a hydroxyl group. Means on benzene ring there will be a OH group present on that ring. That benzene ring with OH group is known as phenols, and phenols are the compound containing a hydroxyl group attached to an aromatic ring. Phenols are generally colorless, but they acquired color when they comes in contact with air. Why they acquire colors while reacting with air? Because they get oxidized in air. The phenolic group can be detected by the following test. Number 1 test is litmus test. Phenols is a weak acid. That's why they give red color with litmus paper. This reaction is very important. The dissociation of phenol is water gives the phenoxide ion. Okay, when you react phenol with water, this will give the phenoxide ion. Okay, next is ferric chloride test. Phenol reacts with ferric ions, means phenol C6H5OH reacting with FeCl3 ferric chloride, then the compound will be of violet color complex. Okay, so this is also very important. Next is test for aldehydic and ketonic groups. So aldehydes and ketones are considered as a carbonyl group, and carbonyl group consisting of a carbon atom bonded to the oxygen atom by a double bond. Number 1 test is 2,4-dinitrophenylhydrazine test, that is also known as 2,4-DNP test. So in this test, 2,4-dinitrophenylhydrazine is used to qualitatively detect the carbonyl group of aldehyde or ketone. So with the help of this test, we can find out whether the compound contains a carbonyl group or not. A positive result is indicated by the formation of an yellow or orange-red precipitate of 2-dinitrophenylhydrazone. If a compound has a carbonyl group, then on reacting with 2-dinitrophenylhydrazine, there will be a formation of yellow or orange-red precipitate of 2,4-dinitrophenylhydrazone. Okay, for example, you have acid aldehyde reacting with 2,4-dinitrophenylhydrazine, then this will lead to the formation of acid aldehyde 2,4-dinitrophenylhydrazone. And if you have ketonic group, that is acetone, reacting with this 2,4-DNP, then this will lead to the formation of acetone 2,4-dinitrophenylhydrazone. Second test is sodium bisulfide test. Most aldehyde and ketone gives bisulfate addition product with sodium bisulfide, which is a white crystalline in nature. Okay. Next is the differentiating test for aldehyde. Differentiating test for aldehydes, we have number 1 is Schiff test. First of all, Schiff reagent has the structure like this. Okay, aldehyde gives pink or magenta color with Schiff reagent. As you can see here, 3 moles of aldehyde when reacting with Schiff reagent, that is colorless, will lead to the formation of pink or magenta color compound. Second test is Tollens test. First of all, you need to remember this point. Tollens test is ammonical silver nitrate. Okay, this is very important. The formula of Tollens reagent. So Tollens reagent is ammonical silver nitrate. Aldehyde react with Tollens reagent to form elemental silver accumulated onto the inner surface of the reaction vessel. Okay, the reaction is this. Next is the differentiating test for ketones. Number 1 test is meta-dinitrobenzene test. Ketone reacts with meta-dinitrobenzene test to give a violet coloration compound. Second test is sodium nitroprusside test. The anion of ketone formed by a alkali reacts with nitroprusside ion to form a red colored complex. When a ketonic ion reacts with sodium dinitroprusside, then the compound formed will be of the red color. Next is test for carboxylic group. Number 1 test is the litmus test. On reacting with litmus paper, carboxylic acid turns into blue litmus red. Turns the blue litmus into red. Second, the hydroxyl group is far more acidic than that in alcohol. The hydroxyl group present in carboxylic acid is more acidic than present in the alcoholic group. Second test is sodium hydrogen carbonate. Carboxylic acid reacts with sodium hydrogen carbonate to produce carbon dioxide, which can be seen in the form of effervescence. Carboxylic acid RCOOH reacting with NaHCO3, that is sodium hydrogen carbonate, gives the RCOONA and a CO2 gas. Okay. Next is the Ester test. Carboxylic acid on reacting with alcoholic group forms the ester compound, and that can be identified by the presence of fruity smell. Next is test for amines. Amines are the derivative of ammonia in which one or more hydrogens are replaced by alkyl or aryl group. For the test of amines, we have our number one test, that is solubility test. As you know it very well, amines are the basic in nature, and these amines turns red litmus into blue. Okay. Next is carbamine test. When primary amine is treated with alcoholic potassium hydroxide, that is KOH, alcoholic KOH, and chloroform, that is CHCl3, then this leads to the formation of an offensive smell of isocyanide. Okay, so in simple language, you can say when primary amines reacts with alcoholic KOH in presence of chloroform, this leads to the formation of isocyanide. Okay, as you can see here in this reaction. Third is azo-dye test. This is very important test in case of amine. This test is given by aromatic primary amines. In this test, aromatic primary amines react with nitrous acid to form the diazonium salts. These diazonium salts undergoes a coupling reaction with beta-naphthenol to form orange colored dye, that is known as azo dye. As you can see here, aniline is reacting with nitrous acid, that is HNO2, in presence of HCl. Then this will lead to the formation of benzene diazonium chloride. And this benzene diazonium chlorides undergoes a coupling reaction and reacts with beta-naphthol. And on reacting with beta-naphthol, this will lead to the formation of an orange colored dye, that is known as azo dye. Okay guys, so this was all about distinguished test of different functional groups. Now, in case if you are new here at our YouTube channel, you can like, share and subscribe. And if you have any query, you can mail us or contact us. Complete information is given on your screens. Now, a very important announcement. If you are preparing for CSIR UGC NET, you can follow Neha Taneja ma'am on Unacademy platform. If you are interested, you can go through with this detailed paid classes. After taking these detailed paid classes, you can use referral code NEHA, that is NEHA, and after using this referral code, you will get 10% discount on total fee. Thank you very much guys. I hope you all like the video.